and welcome to the Partner Practice Enablement Bootcamp for Windows Azure. This 8-module training series is designed to help Microsoft's partners build their skills around selling and deploying Windows Azure. In Module 1, we will look at some of the foundations of the Azure infrastructure. These include creating and managing virtual machines and storage, automation through PowerShell, and an introduction to Azure Virtual Networks. Our instructor today will be Michael Washam. Michael is the current CEO and co-founder of Opsgility, an organization focused on Windows Azure training. Michael is also a Microsoft alumni with a wide range of experience across Windows Azure that we are pleased to bring to you through this training. Without any further delay, let me turn the floor over to Michael. Michael?
And thank you for the introduction. This session is an introduction to Windows Azure Infrastructure Services. On today's agenda, we're going to discuss Windows Azure Virtual Machines, Windows Azure Storage, how to use automation with Windows Azure PowerShell and PowerShell commandlets, and virtual networking, which comprises hybrid connectivity such as site-to-site virtual networking and point-to-site virtual networking. To get started, I'd like to compare the traditional stack of a traditional data center with the various compute models offered by Windows Azure. So starting on the left, traditional data center, kind of start from a bottom-up perspective. You can see that in a traditional data center, you own everything from the hardware, the underlying servers, the network, the switches, the cabling, all the way through virtualization, operating system, the network, firewall data, and applications. And this is how computing has been for a long, long time. Where the cloud comes in different, and where Windows Azure specifically comes in different, is offering different pieces of this as a service. For instance, virtual machines, the topic of today, offers you very, very, very deep control over your applications and your virtual machines by providing the virtualization and the hardware aspects of the stack to you as a service. So you still have full control over the operating system, the virtual networking aspect, the firewall, the data, and the applications, but you're no longer constrained by managing the underlying physical servers, racks, the switches, cabling, power supply, cooling, everything that goes along with managing your own data center. The virtualization layer is also built into the Windows Azure platform. There's APIs for creating, destroying, copying virtual machines, virtual disks, etc. Moving further up the stack in Windows Azure space is Cloud Services. Cloud Services is another option for creating new applications that allows you to not even have to worry about the underlying operating system, so don't have to worry about what patches are applied or whether the disks are defragmented. That actually is taken care of you by the platform. So you're really focused on your applications and your data and some underlying network capabilities if you happen to be doing some more advanced deployment technologies. Moving a little further with websites and mobile services, you can see that they're pretty much the only thing that your job as an application developer or an IT architect is to manage these applications and underlying data. The platform handles everything else for you, and these are very specific but very powerful technologies that allow you to focus more on your application. So what scenarios are great for virtual machines? Well, there's 3 key scenarios I really want to call out. Production deployments is the most obvious. In a physical data center, you have to manage all those physical servers. So whenever servers are end of life, you are responsible for bringing new ones in, going through procurement, getting them set up, managing firmware, managing updates, patching, etc. Virtual machines, as you saw, you don't have to manage the actual underlying virtualization technology or the hardware. So doing rapid deployment of new or existing business applications, deploying them up in the cloud, is a perfect scenario for Windows Azure. Windows Azure virtual machines are fully supported, and when configured correctly, offer a 99.95% SLA. So the next scenario that I really want to call out is development and test. Development and test is great for IT pros and developers. And you hear the word development and test, automatically lean towards developers. But as a former SharePoint consultant, I can say that the cloud is a really powerful piece of technology for consultants in the IT space. For instance, if you are a SharePoint consultant, or I don't want to single out SharePoint, but if you're a consultant or an IT professional that routinely has to set up big environments for testing and using Hyper-V, you have to carry around a pretty substantial piece of hardware to run all these virtual machines locally. The cloud is wonderful in this aspect, as you can spin up as many virtual machines as your environment needs, do your testing, delete them, or just shut them down whenever you're through with them so you're not paying for them. So beyond production deployments, the Windows Azure virtual machines are great for just testing out new scenarios and trying things out without having to have the upfront capital expenses of buying all this physical hardware to test it out in. From a developer's perspective, spinning up a virtual machine that has your development environment, Visual Studio, running automated build servers, continuous integration. Perfect scenario for doing testing new and technology that you're still learning, or actually just setting up to have a more agile development environment for whatever applications you happen to be building. The third scenario I really want to call out, because this one is my personal favorite, is rapid development and experimentation. In most enterprises or ISVs today, having the ability to automatically spin up hardware resources for testing out some new application or getting a new application online, there's always this big delay. Anytime you say, hey, IT, I need 22 servers to do a new SharePoint form, there's obviously some consideration that maybe that's not something that you can instantly have. And obviously, you certainly want to think that through. But when Windows Azure, literally you go in, there's no wait. You provision as many virtual machines as you want to test. If you need to build out a giant server farm, you can do it. If you need to spin up a single server to test out an experiment for, a new web campaign or just a new piece of technology, you can do that without having to wait on procurement and shipping and setup of the actual physical infrastructure. So let's dig into a little bit deeper with that and kind of do some compare and contrasting of how deploying in the cloud looks compared to deploying on premises. So if you were deploying in a traditional data center and you were starting from scratch, which in many cases you are, if you're deploying a large new application, you may have to extend existing network infrastructure, etc. But if you're starting from scratch, or if you're extending, let's say first thing you need to do is you need to make sure the networking infrastructure is set up. This means you need to make sure that your new servers have switches, they have routes enabled so they can get traffic from the internet. If they're accessing other resources, maybe they have VPN tunnels that need to be set up, etc. So this is itself could be a potentially arduous process, just ensuring that the networking infrastructure is set up for your application. The next step is you need to actually set up these servers. Now this is assuming that you've already done the wait of procurement, waiting for the servers to get to your data center. But now that they've arrived, what do? You have to set them up. This is configuring network cards, configuring storage, making sure firmware is up to date, making sure your disks aren't bad, making sure everything works as told, and then configuring the physical aspects of the server to make sure everything's turned on. Third is you have to install and patch the OS. So it may not sound like such a big deal until you realize that you could be doing this a whole lot of time, and then you realize that you're spending a lot of time installing operating systems on these servers. And finally, installing and configuring the apps. This is something you really can't get away from as long as you're on a virtual machine or a physical machine. Every application needs some stand-in, some kind of configuration to make it work. And now, you've went through this whole thought process of deploying applications, and this is obviously nothing new. People have been doing this for years and years and years. But now you've been asked, how do I do this for the brand new team that just came online in marketing that's going to talk about this one product? Great. You have to do this whole thing over again, rinse and repeat. Hopefully you can reuse some of the networking infrastructure that was just built. But for all intents and purposes, this is a pretty big experience. Now moving directly to the cloud, nothing else. What does deploying in Windows Azure buy you versus a traditional data center? The first thing it buys you is whenever you configure the network settings, you're not configuring physical devices. You're not running cable. You're not tearing down walls and putting in new switches. You're just configuring a virtual network up in the cloud using a web browser, which isn't nearly as traumatic of an experience. Second thing you're doing is you're going to create virtual machines. Whenever you create the virtual machines, you select the operating system that comes with it. So at least you get to skip the operating system install piece. So the cloud does give you some software agility in addition to the physical hardware agility. So you're not setting up servers, you're not setting up racks, and you're not installing an operating system. Beyond that, it's where it gets a little bit more similar. You're still patching the operating system. You're still managing the operating system. You're still installing and configuring the applications. If you're deploying SharePoint, you have to install and configure SharePoint. And if you have multiple environments, again, you have to rinse and repeat. You have to do the same scenario again. And granted, this is still a much more agile scenario because so much is taken care of you by the platform, but it's still some underlying work. Now, where Windows Azure and cloud in general really shines is the cloud is automatable, which means that all these resources in the cloud, I can programmatically create and destroy. They're just resources. I'm not attached to my servers anymore. It's not, hey, that's my favorite server. These are just resources that you can programmatically create, and when you're done, you can programmatically destroy. And you do that with automation. In the case of Windows Azure, automation for IT professionals, that's mostly going to be PowerShell. But from a developer perspective, you have a full REST API, and if you're an IT professional not on Windows, there's a full set of command line tools that run on Mac and Linux as well. So automation is key in the cloud. So how this scenario would differ with the cloud is, in automation, of course, is the first thing you're going to do if you know that you're deploying lots of different scenarios that use very similar configurations You're going to identify these and figure out what it is that's actually repeatable. Once you're there, you're going to invest some time and energy into making automation. So this may be writing scripts, it may be writing some code, it may be using tools that allow you to provision these servers in an automated and configurable way. Once there, you're going to execute. Whatever you just created in your automation, you're going to execute and it will be there. So if you wrote a script that will provision 2 web servers, 2 app servers, and 3 SQL servers, the only thing you have to do is execute that script after it's written, and you can get an exactly identical environment every time you execute the script. The final thing is there's always going to be tasks that just aren't really worth writing an automation for. Installing some application that you really don't ever plan on doing again. Perfect example. Now the beauty here is, say I do need to reuse the same environment in a different environment. Say I need to have this same set of servers available for the marketing team or the sales team or the engineering team. All I have to do is change a variable in my script that says where it will be created at or whatever, and execute, and I have the exact same environment. I don't have to go through the process of recreating this each and every time, and which is of course subject to major errors and configuration differences. Now that you know the why virtual machines and why the cloud is just absolutely great, what can you actually do? Whenever the rubber hits the road, what is actually there? In Windows Azure, the images that are available by default are, of course, Microsoft images, Windows Server 2008 all the way up through Server 2012 R2, SQL, SharePoint, BizTalk, Visual Studio. Oracle has images available for you to provision and use. Open source images, so if you're a Linux user, you have in platform, you have OpenSUSE, CentOS, Ubuntu, and SUSE Linux Enterprise Server. And if those don't meet your needs, then you can use a VM Depot images, which are a bunch of gallery images created specifically by the community. So these are pre-configured images that have a very wide variety of open source solutions available to them. From a Windows Server perspective, what exactly is supported? So various Windows Server workloads, so SQL Server, SharePoint, BizTalk, System Center. And whenever you look at Windows Server itself has multiple roles and multiple features that you can run. So for a very detailed look on what exactly is and is not supported, because it's not 100% compatibility yet, see the KB article 272.1672 for very deep, thorough information on what exactly is supported in Windows Azure. So the very first approach you should take whenever you're looking at the cloud is cloud first provisioning. A lot of customers that I've talked to in the past always think that the first thing they need to do is create the virtual machine locally using Hyper-V and then upload it. And while that's a very valid scenario and something that you can absolutely do, it's actually probably simpler in most cases to start with cloud first provisioning. And how you do this is you start with 3 different entry points: management portal, which is just a web-based portal, the scripting interface, which is Windows, Linux, or Mac, and of course a REST API, which is any language, any platform, programmatic. Pick your entry point, such as management portal, and then the next thing you need to do is pick one of the images that I just mentioned. So Windows Server, Linux. Once you pick the OS image, you choose the right image or the virtual machine size, starting from extra small all the way through A7, and I'll show you a table of what each of those instances actually looks like soon. And once you've chosen the image, the VM size, and the entry point, what will happen is a copy of that virtual machine image will be made and stored in your Windows Azure storage account as a new disk, which is just a writable VHD, and your virtual machine will actually boot from that disk just like you would running locally with Hyper-V. So the virtual machine sizes that are available to you as of today start all the way from extra small with a small amount of RAM, 768 megs, and 1 data disk, all the way up to A7 with 8 cores and 56 gigs of RAM. And this SKU, along with the extra large SKU, can support up to 16 data disks. And each data disk can be up to 1 terabyte in size. So the biggest amount of storage you can currently hold on Windows Azure Virtual Machine is 16 terabytes. In this example, we're going to use the Windows Azure Management Portal to create a new virtual machine. Before I create the virtual machine, I need to create a Windows Azure storage account, which is the entity that actually will store the disks for your virtual machine. So I'm going to go to New, Data Services, Storage, click Create. And I'm going to choose the data center location the virtual machine will be created in, because the storage account has to be in the same location. Call this PP Storage 1. This does have to be a very unique name because it's registered in DNS, so the full name to the storage account is ppstorage1.core.windows.net. And I can turn on geo-redundant replication for additional durability for our data. We'll talk about that in much more detail later, but for now I'll go ahead and keep the default of geo-redundant. So let's click Create Storage Account and give it a few moments to create. Now that the Windows Azure Storage Account is created, let's go ahead and create a new virtual machine by clicking New, Compute, Virtual Machine. And there's two options. One of them is Quick Create, which allows you to quickly spin up a virtual machine. It doesn't have the full image gallery available, and you can also not deploy to a virtual network. But if you're just spinning up a virtual machine based off the core Windows Server or Linux images, this is a really quick and easy option for spinning up a virtual machine. Or if you want a more advanced selection, you can choose from Gallery. And this will pull up the full gallery images of all the Microsoft platform images, the partner images from Ubuntu, CentOS, Oracle. And from here, you can filter deeper into the image gallery. So I can pull up all the Windows Server specific images, the SQL Server specific images, Visual Studio, etc. So I'm going to go ahead and choose Windows Server 2012 R2 Data Center and walk through and create a virtual machine from it. You can see each image, the Windows Server 2012 R2 is a great example, will be updated occasionally with patches and other updates for the image, and you can grab a previous version or the current version. So here's where I'm going to name my virtual machine, and this does have to be unique for the same cloud service, and I'll talk about cloud services shortly. Here's where you can select instance size, all the way from small to A7, and I'm going to pick a username, so demo user, and a complex password. So the next thing I need to do is I need to specify a cloud service. So a cloud service acts as a container for your virtual machines. You can have one cloud service and multiple virtual machines, or you can have one virtual machine per cloud service, however you want to do it. And in the next few slides, we'll talk about this architecture in detail, about what it really means. So the cloud service DNS name does have to be globally unique, just like the storage account name. It has a full DNS path to it. So I'm going to call this PPE Demo Service 1. That should be unique. Now let's specify a location. So I want this to be in the same location as the storage account I just created. PPE Storage 1. And we'll go ahead and click OK to create the virtual machine. And the last screen you just saw was about network endpoints, and we'll talk about that a little bit more in a few slides from now. So now this will take a few minutes to create the virtual machine, and then we can come back to this in the next demo and show how to connect this to another virtual machine. Now that we have walked through creating a virtual machine using the Windows Azure Management Portal, let's look at how all this is architected behind the scenes. Cloud services. What exactly is a cloud service? A cloud service is a container for virtual machines that provides a network and security boundary. In this example, Contoso Service is the name of the cloud service, and it is addressable via the URL contososervice.cloudapp.net, and it is mapped to a public IP address of 137.135.67.36. A virtual machine has full networking connectivity to other virtual machines in the same cloud service. By default, it cannot communicate directly with other virtual machines in separate cloud services. Only virtual machines in the same cloud service can be load balanced from external internet traffic using the Windows Azure Load Balancer. Windows Azure also provides basic name resolution services to virtual machines in the same cloud service. It is possible to allow communication between virtual machines in separate cloud services by deploying cloud services that need to communicate into the same virtual network. In this example, Cloud Service 1 and Cloud Service 2 are both deployed in the same virtual network and are allowed to have direct network communication with each other. We'll discuss virtual networks later in this session and in much more detail in the next session. Another Windows Azure I want to discuss involves high availability. When deploying virtual machines where there are more than one virtual machine will service a workload, such as a set of web servers or domain controllers, it is highly suggested to create them in an availability set. Putting servers that service the same workload in an availability set tells Windows Azure to provide data center high availability to the servers. What does this mean? It means Windows Azure will put the servers on separate physical racks in the data center, so your servers have physical redundancy at the server, power, network level. If a failure even at the rack level occurs, a minimum of half of your application servers will still be available on separate physical hardware. Windows Azure now has some basic knowledge about the structure of your application. When updating the underlying host, Windows Azure will perform a rolling update and only take down a portion of your servers for the actual update. To achieve the 99.95% SLA, availability sets are required. Putting these features together, you can see how to build an end-to-end highly available solution. Using the load balancer to distribute traffic along with availability sets to ensure that your virtual machines are always available, Windows Azure Virtual Machines makes it very easy to be highly scalable and available. In this example, I'm going to walk through creating a second virtual machine and put it in the same cloud service as the first one that we just created. As part of this demo, I'm going to walk through creating an availability set so you can see how to group two virtual machines that would do a similar workload, such as two web servers, into an availability set so you'll get Windows Azure data center level high availability. So before I create the second virtual machine, I need to create the availability set. So I'm going to open up the configuration tab for Demo VM1, select an availability set, and create an availability set since one doesn't exist yet. So I'll just call this one Demo AV Set and click the Save button. Now I do need to wait for this availability set to be completely configured before I go back and create the second virtual machine so it can be created as part of this availability set. Now that demo VM1 has been updated to be in the demo AV set, let's go ahead and create the second virtual machine. So go back to the gallery option and we'll choose server 2012R2. And this will be demo VM2. Same strong password. And on the next screen is where I get to choose the existing cloud service. So again, I could create a new cloud service and have this virtual machine in its own container, or I could choose the existing cloud service from the previous example, and now that's going to be part of that same cloud service. So whenever this virtual machine boots up, it'll actually be part of that. It'll have name resolution between these two servers and direct network connectivity. So I'm going to put these in the same storage account, and here I can also choose the availability set that we just created for demo VM1. Go ahead and click OK, and now this virtual machine will be provisioned. After a brief pause, the second virtual machine is now up and running. So let's go ahead and log into both of them. I'm going to start with demo VM1, and I'm going to click to connect and use remote desktop to log into this virtual machine. I'm going to do the same thing with demo VM2 so we can demonstrate network connectivity. Okay, so I've been logged into demo VM1, and as soon as the console lights up, we're going to validate that we do have network connectivity between the two virtual machines. Okay, so I'm going to go ahead and bring up command prompt. Tell it, yes, I do want to enable file and printer sharing. And now I'm going to try to ping demo VM2. So you can see I am getting name resolution. So I pinged demo VM2 and I got this internal DNS name with a 100.71.20.82 IP address, but I got a request timed out message. All this is saying is that DNS name resolution is working, so my virtual machine is resolvable, but I can't actually get a response via ICMP yet, which is ping. So let me switch over to demo VM2 and try to enable ICMP. So under administrative tools, I'm going to go into Windows Firewall with Advanced Security and Inbound Rules, and I'm going to enable file and printer sharing echo request ICMP. This is basically turning on ping. So now that ping is enabled, I can go back to demo VM1 and run the same command, and now I'll actually get ping response. So in this demo, you saw how to add a second virtual machine to the first virtual machine's cloud service. You saw that virtual machines within the same cloud service do have name resolution between the two, and that once you enable ICMP on the Windows firewall, and this goes the same for Linux, then you can actually ping between the two virtual machines and have full network connectivity. Let's now discuss the underlying storage for Windows Azure virtual machines. There are two storage-related entities in Windows Azure that you should be aware of, images and disks. Images are supplied by the Windows Azure platform, by Windows Azure partners, and of course you can create your own images. An image is simply a VHD that has an operating system on it that has been generalized for creating multiple instances. On Windows, this means the virtual machine has been sysprep. On Linux, Windows Azure Agent must be run. An image can be created on premises, uploaded and registered with Windows Azure, or can be created directly in Windows Azure using the capture feature. Disks are writable VHDs used by virtual machines. They can either have an operating system on them and be bootable, or they can just be data disks. Disks are created when you create a virtual machine or when you upload existing VHDs and register them with Windows Azure. Let's take a look at how the disks of a virtual machine are laid out. The C drive, or the OS disk, has a maximum capacity of 127 gigs. The D drive is a direct attached storage to the server your virtual machine is hosted on, as your VM could be moved to another server. Do not keep any persistent data on this drive. Beyond these two disks that all virtual machines have, you can also add data disks to the virtual machines. Data disk can be registered with whatever drive letter you prefer. To summarize, the C drive is always the OS disk, the D drive is a temporary disk that you should not use for anything except temporary data, and data disk can be mapped using the remaining letters. A few things to note: the operating system disk has read-write caching on by default, so it's a best practice to not put any data files on the OS drive. Data disks have no caching on by default. You can change the cache settings for the operating system disk or the data disk. Changing the cache settings of the OS disk does require a reboot. All virtual machine disks are stored in Windows Azure Storage and are highly durable. Windows Azure Storage stores 3 replicas for every file it stores for additional durability. If the storage account has georeplication enabled, an additional 3 replicas of the file are stored in a remote data center location for additional durability even at the data center level. What happens if the physical server your virtual machine is running on fails? As part of the platform, Windows Azure will automatically detect this and move your virtual machine to a new physical server as part of a health check. Disk mobility. Windows Azure also provides the tooling to easily allow Hyper-V-based disks to be moved between on-premises and the cloud. It also provides the ability to move VHDs uploaded or created in Windows Azure back to your on-premises environment. So how do you bring your own server? A few things to know. Windows Azure currently only supports VHD, not VHDX. You can upload your VHDs using third-party tools, but be aware that when using these tools, the VHD must already be fixed. It cannot be dynamic. The recommended solution for uploading VHDs is to use the Add Azure VHD PowerShell commandlet, which supports converting from dynamic to fixed disk on the fly and provides an optimized upload by only uploading the written bytes on the disks. The process is simple. Upload the VHD, register the VHD as a disk or image, and then provision virtual machines. How do you create an image? The easiest way is to create a new virtual machine from one of the base images. Customize a VM, install software, registry keys, startup scripts, or whatever you need to customize the OS. Generalize a VM. In Windows, this means using the sysprep tool, and in Linux, it means using the Windows Azure agent. Finally, you'll capture the VM. This is a button in a portal or a scripting command that takes a virtual machine and saves it to your image library. From there, you can create multiple virtual machine images that are identical to your image. What if you need to move large amounts of data into Windows Azure? Maybe your dataset is so large that it just isn't practical to upload it or download it over the internet. Windows Azure has recently announced a data import and export service is in preview. With this service, you can load your existing data onto physical disks and ship them to Windows Azure. Windows Azure unloads the disks and restores the data on a specified storage account. If you need to get the data back out, simply ship Windows Azure empty disks, and the data will be put on the disks and sent back to you. Here are some of the key details of the service as it is today in preview. See the following post from the Windows Azure Storage Team's blog to learn more about this preview, all the details, all the limits and things you can do, and also to keep up to date on the latest about this service. Now in this example, I'm going to walk through how to add additional storage to your Windows Azure virtual machines, and then we're going to walk through some of the underlying concepts of how you can actually manage this storage. So to get started, I'm going to select Demo VM1, and I'm going to add a new data disk to this virtual machine. So I'm going to click Attach Empty Disk, and let's add a 1023 gigabyte or almost a terabyte disk to this VM. Go ahead and click OK, and it'll take a few moments for this disk to actually attach and surface inside of the virtual machine. So while that's doing that, let's go ahead and go back to the virtual machine that we're actually remote desktop into and pull up Administrative Tools and Computer Management. Because whenever this disk is actually attached to the virtual machine, it's going to be uninitialized and unformatted. So we're going to want to walk through and prepare this disk. So under Disk Management, you can see that the Initialize Disk Wizard popped up because it detected a disk that wasn't initialized. So I'm going to go ahead and click OK, and let's format this disk. So I can do a new simple volume, give it a drive letter, E through Z, and we'll call this data. Press Finish, and let it actually format the disk. Okay, so the disk is up and running. So now let's pull up Windows Explorer and put some data on it. I'm not going to do anything crazy, just enough to show that there is data on here. Create a new text file. Okay, so now we have data on our text file on our new data disk. So what I want to do with this now is I want to take a copy of this disk and attach it also to VM2. So to do that, I'm going to use a third-party tool called Cloud Explorer. Cloud Explorer is essentially it's a freeware tool. They have a paid version, which is also very nice as well. But the freeware version basically allows you to manage your storage accounts. So to enable to do that, I need to get my storage account name and key. So I'm going to go in here and copy my PP Storage 1 key, or name I should say. Go back to Cloud Explorer, File Accounts, New Windows Azure account, and paste in the name. Now I need to paste in the key. And I can get that by clicking Manage Access Keys, copying the primary access key. This is basically an authorization token that is used to authenticate your request to your storage account. Paste in the secret key and click OK. And now I should have access to my storage account. So as you can see, here's the virtual hard disk, the two from VM1, VM2. These are both the OS disks, and this is the terabyte disk that I just made. So I'm going to create a new container. In a container, you can think of it kind of like a folder, and call this backup. So with my VHD, I'm going to copy this terabyte disk to the backup folder. And this is on a running VM, by the way. Probably not the best approach if you want to do that to a disk that's actively being written to, though, because it could generate non-clean writes. So now that the VHD is copied over to backup, let's create a new disk in Windows Azure that points to this copy. So I'm going to go back to my virtual machines management section, go to disks, and I'm going to click Create, and browse to this backup. And we'll call this copied data disk. And as soon as this disk is created, we can then go back to VM2 and attach this disk to VM2 to show that it actually is accessible from a VM. Okay, so it's created. Let's go to virtual machine instances, VM2, and attach disk. And now you can see the copied data disk. That's the only disk I have in my subscription. I can hit check to enable that and attach it to the virtual machine. So now whenever we go to VM2 and pull up Windows Explorer, we should see a new drive pop up here in just a moment. There it is. Here's our data drive. And you can see the new text document is data added from VM1. So we successfully copied a terabyte disk between drives. So this is a copy. It's not writing to the same disk. So something to keep in mind. So in this demonstration, you've seen how to attach new storage to an existing virtual machine. You've seen how you can use third-party tools such as Cloud Explorer to make a copy of that, or a backup of the VHD into a different container. And you've also seen how you can register that disk in the disks folder inside of virtual machines and attach that new disk to another virtual machine. Windows Azure provides automation capabilities in the form of a management REST API and scripting tools that work across Windows, Mac, and Linux. Let's review some of the capabilities that the scripting tools provide. The scripting tools provide full support for infrastructure services in the form of the Windows Azure PowerShell commandlets for PowerShell users or the cross-platform scripting tools that are built on Node.js but run on Windows, Mac, or Linux. Some of the things you can do with these tools: you can provision, you can remove, stop, and start. You can import and export virtual machine configuration settings, provide support for creating Windows virtual machines and Linux virtual machines. From PowerShell, you can actually domain join virtual machines at provisioning time, so it saves you a lot of time for advanced provisioning scenarios. You can fully customize virtual machine with data disks and endpoint configuration at boot. And of course, you can automate virtual network settings, so adding and removing virtual networks. And finally, there's really advanced support for remote PowerShell for doing advanced management and monitoring. Now that you've seen how to create multiple virtual machines using the Windows Azure Management Portal, I want to show you how to accomplish similar tasks or even more advanced using PowerShell with automation. So in order to get started with that, you need to launch the browser and go to windowsazure.com. Click on Downloads, and then there's the Downloads at the very bottom under Command Line Tools. You can see the install link for the Windows Azure PowerShell commandlets. So once you actually run through the installation, you'll want to launch PowerShell ISE and load the Azure PowerShell commandlet module up into your environment. So there's two options to do this. You can run import module just Azure if and only if you've actually rebooted after you've installed the commandlets for the first time. Until then, you can run import module and have to have it give the full path to the PowerShell commandlets module itself. So this would be Microsoft SDKs, Windows Azure, PowerShell, Azure PSD1. Either way will work. It's probably the easiest way is going to be to install the commandlets and reboot, then import the module. Now that the commandlets are loaded up into your environment, though, you need to configure PowerShell to have access to your subscription. And to do that, run a commandlet called get Azure publish settings file. So type in this commandlet, hit F5, and this will actually launch the browser to a specific page. If you're not already logged in, it'll ask you for your credentials. Give it your credentials, and it'll give you a publish settings file that you can save locally to your file system. Once this has been saved, you can import this using the import Azure publish settings file commandlet and basically give it the full path to the file you just downloaded. And this file actually has a management cert that's been created for you that has full access to your subscription. Press F5, and now your subscription has been imported. And you can see all the subscriptions you have available to you by running the Get Azure subscription commandlet, and you can export out the subscription name if that's all you're interested in. So my published settings file only had access to one subscription, but it can have more than one. So just keep that in mind whenever you're doing PowerShell to make sure you're always operating on the current subscription. With that in mind, we're going to create a virtual machine. So to create a virtual machine, we need to tell it which subscription, and we also need to tell it which storage account to use. So I'm going to get a list of all the storage accounts that are available for my subscription. And just like before, I'm going to select out just the storage account name. So you can see here's the storage account we created for the previous demos. So what I want to do is I'm going to call a commandlet called set Azure subscription. And I'm going to give it the subscription name that I just showed you, the one that was returned back from Get Azure subscription. And I'm going to set a property on this subscription settings called current storage account name. And what this is telling it tells the PowerShell commandlets anytime I use a PowerShell commandlet that is using storage, for example, creating a virtual machine, to use this storage account for creating disks or underlying any blobs that's needed by the commandlet. So now our subscription is configured, so whenever I create a virtual machine, the disks will automatically go into this storage account specified as current storage account name. So now the next piece of information you need to know to enable to create a virtual machine is you need to know the image name, which virtual machine image we're going to use, just like we saw in the gallery, the location, which data center location we're going to create it in. You need to know the username for the administrator, and finally you need to know the password. So two of these we can figure out ourselves. So we can say demo user and make a complex password. But image and location, the only way to identify those is to use Windows Azure PowerShell commandlets. So I'm going to call get Azure location and enumerate all the locations that are available to my subscription. Okay, so get Azure location select name, and I had a typo in the previous command. I should have called select name. So just like you saw in the portal, it's West US, so we can fill that in as our data center location. Now for the image name, I'm going to run get Azure VM image, and this will actually give me quite a bit of information, and I can go through and look at all the different image names and kind of figure out what they are based off just the image name itself. And this is a name you actually need to use for creating it with PowerShell. So based on this information, I'm going to pick the Server 2012 one, but you notice you don't actually get the published date or anything else by filtering it this way. So how to do that is you can say get Azure VM image and just run it raw, and it will give you every image, including published date, image family, etc. So I can do things like get Azure VM image and use PowerShell's built-in filtering capability where image family equals, if I was curious about all the SQL images, I could say like SQL, and this will give me a list of all the images that have SQL as the image family. And then I could sort by published date. I could grab just the image name, whatever I want to do. So with this commandlet, you can get some fairly advanced filtering capabilities to figure out which virtual machine image you want to use. So now we have pretty much everything we need for creating a virtual machine. So to do that, the next step, I'm going to call a commandlet called new Azure VM config, give it the name. So that's a variable I didn't create, so let's just make that up as we go. So demo VM PS, pick the image name, pass it the image variable we just created. The instance size is small. And as you notice, I can also specify the availability set name here. So if we were creating multiple virtual machines that needed to go in an availability set, I could specify that here. I can change the host caching for the operating system disk, set the disk label, and I can also override that current storage account and actually specify the location and the name of the OS disk if I wanted to. So let PowerShell do some of the work for us. So now since I'm provisioning from a image, I need to add some provisioning information. If I was provisioning from a disk, it already has username, computer name, all that, so I don't need to. But since I'm provisioning from an image, I actually need to specify some information for sysprep to use. So I'm going to choose the Windows parameter set. If you notice, there's also Windows domain, which is built in for doing domain join. So I'll specify Windows, admin username, which is our user variable, and password, which is PWD. There's also a couple of other interesting parameters here. I can tell it to reset password on first login. I can disable automatic updates, tell it not to create an RDP endpoint, set the time zone. I can deploy certificates. I can have multiple settings for disabling and enabling remote PowerShell, and I can tell it not to export the private key of any certificates that I want to specify. So there's a lot of advanced things you can do here that we'll talk about a little bit more detail in another session. So the next thing I want to do is let's have this virtual machine boot up with storage. So we'll add Azure Data Disk, create new, disk size in gigabytes, say 100 gigs. This will be called our data, and I'm going to put this on LUN 0. And one thing to keep in mind if you're not a PowerShell guru is how this works is new Azure VM config actually doesn't create the virtual machine. It creates a configuration object, which I'm then taking that object and passing it using a PowerShell pipeline operator to another commandlet, which is add Azure provisioning config. Add Azure provisioning config takes that configuration object, adds a provisioning information to it, and then passes it along the pipeline to another commandlet, add Azure Data Disk, which modifies it as well. So all we're really doing with this chain of commandlets is creating an object that will have all of our virtual machine configuration in it. So if I wanted to add a second data disk, do the same thing, and I can put this on the next available one. And I can also do the exact same thing with network endpoints. So I can say add Azure endpoint, name, web, protocol, specify it's going to be TCP since this is going to be a HTTP endpoint, local port 80, public port 80, and At this point, I could enable load balancing, I could set an access control list, and a lot of other stuff that we'll talk about in the networking session that's coming up after this one. So now that we've created our virtual machine configuration object, I can store this in a variable, or I can actually pipe the results out to the new Azure VM commandlet. So let's go ahead and store this in a variable, and then I'll essentially do the same thing and pipe this out to the new Azure VM commandlet. And with the new Azure VM, I have to specify the cloud service name. So this would be demo VM PS123A, just to make sure it's unique. And location, the variable that I put in here. Now, one quick tip I want to point out is if you're trying to build an automated script, chances are you're going to be creating cloud services and storage accounts named dynamically, so you need to know whether they're available. There is a PowerShell commandlet called test as your name that'll tell you this. So for instance, if I wanted to test whether a cloud service name was available, and the cloud service name I want to test for is called test, I run test as your name -service, and it returns back true. And in this case, what test is telling us is that this cloud service already exists. So it's not available for you to create a new one. And you can do the same thing for storage or service bus namespaces as well. Make sure you get your parameters correct. So the key is, if it is unique and it's available for use, it'll return back false, which means that the resource doesn't exist and you can actually use it. So now that that side bit is out of the way, let's go ahead and run this script and make sure I don't have any typos and actually create the virtual machine. So this is broken down into two different operations. So the first succeeded comes back is basically meaning that new Azure VM created a cloud service on your behalf. And you'll get another operation ID, hopefully a succeeded, whenever it actually goes and creates a virtual machine. So a couple of things to keep in mind here is this is not a transactional commandlet. So if I go and I create the virtual, or I specify all the information and it creates a cloud service, but for some reason my VM couldn't get created, maybe I had a configuration error, it will actually create the cloud service, but the virtual machine may not be created too. And if that's the case, you'd see a succeeded and then a red chunk of error. And in order to run the script again, you'd either have to choose a different cloud service name or create a new one. And I'm going to talk more about PowerShell creation because there's quite a bit to it beyond this in another session. So in this session, you learned how to download and set up your PowerShell commandlets, how to import your publish settings file, how to set the current storage count, and the very basics of walking through and creating a new virtual machine. Now let's briefly review Windows Azure Virtual Networks. What is a virtual network? Think of a virtual network as your virtual branch office or data center in the cloud. Virtual networks provide a private IPv4 network that allows you to control the addressing and connectivity for servers in the cloud. Windows Azure Virtual Networks enables several key scenarios. The first is a hybrid public/private cloud scenario. Virtual networks allow you to have direct connectivity between your on-premises data center and your Windows Azure environment. This allows applications running in Windows Azure to securely communicate with required resources that happen to be on-prem. The second scenario is enterprise identity and access control. Virtual networks make it possible to easily extend your existing enterprise identity to the cloud, so your applications are protected and your users have a single identity to manage for on-premises resources and cloud resources. The third is monitoring and management. Using virtual networks allows you to leverage your existing monitoring and management investments in the cloud. By providing direct connectivity to your data center, servers in Windows Azure look just like servers running locally. Finally, virtual networks allow for advanced connectivity requirements for applications running in Windows Azure. Workloads such as Active Directory, which require persistent IP addresses, or more advanced architectures where you need to combine Windows Azure Cloud Services into a single network. There are multiple options for enabling hybrid connectivity in Windows Azure. The first option is site-to-site connectivity, and it is fully supported and is currently in general availability. This option allows you to configure a hardware or software VPN device to connect entire networks on premises to the Windows Azure Virtual Network. The second option is point-to-site connectivity, and this is currently in preview. This option allows you to connect multiple individual Windows-based virtual machines directly to the Windows Azure Virtual Network. The third option, which was announced in September, will allow you to connect your network to Windows Azure's network directly through a high-speed link. More information on this option can be found on the blog link below. In the next session, I'll spend much more time discussing the details of Windows Azure networking, including hybrid connectivity. In this session, you were introduced to Windows Azure virtual machines and learned some of the capabilities such as instance sizes, storage capacity, and an introduction to architecting deployments for high availability using availability sets. We also discussed some of the details with storage, such as storage accounts, images and disks, and how to use storage tools such as Cloud Explorer to manage your storage. From there, we had a brief overview and introduction to automation using the Windows Azure PowerShell commandlets. We ended the session by providing an introduction to Windows Azure Virtual Networks and discuss some of the key scenarios for this technology, such as hybrid connectivity, enterprise identity, monitoring and management, and advanced connectivity requirements such as persistent IP addresses and connectivity across services. Here are some of the suggested exercises and videos to learn more about the technologies discussed in this session. Here are some additional resources that are directly related to this session if you'd like to go even deeper. Finally, here are some really great resources for Windows Azure in general. Coming up next, the next session will provide a much deeper dive on networking using Windows Azure Virtual Machines and virtual networks. Thank you very much for watching the session.